So how do we solve this? An object being projected from the height of a building. So let's get a picture first. The building could be from the height of 80 meters. I mean, it could be a building, it could be anything. But let's assume that this person stayed on the building. Let's assume that was a building. We are not told that was a building, but any elevated surface. It could be a building, it could be a mountain, it could be whatever. So the person stays here and projects an object, 80 meters above the ground. That's 80 meters above the ground. This 80 meters above the ground. We know the height where it was projected from. With an upward velocity of 40 meters per second. This initial speed is 40 meters per second at an angle of 30 degrees to the horizontal. Angle of 30 degrees to the horizontal. So what is the time of flight for it to hit the ground? So the object was projected up like this, unlike the other one that was projected down. So for the fact that this body was projected up, it's going to do something like this. It will get to max height, then falls back to where it was projected from, and keeps falling until it gets to the ground, just like this. So this is quite a more complex stuff than the previous one that we worked on. So it gets to a max height, it was projected up like this. So it gets to a max height, and when it gets to a max height, then it starts falling back. So it's going to fall back to where it was projected from, to this angle, to the projection, to the point of projection. So after covering max height, this from here to here is max height. So after covering max height, then it falls back down to the ground. Since it was not cut at this point. So nobody cut it. So it kept on falling until it dropped to this very point. So we're going to get the total time of flight. Time of flight for it to get the max height, falls back to where it was projected from, and keeps falling down to this very place. So that's what we're going to get. So to get the total time of flight is not a big deal, actually. It's not a big deal. First of all, let's get the components of the initial speed. Let's get them. So it's projected like this. So we have initial speed along x, initial speed along y, 30 degrees here. We have a 40 meters per second. Opposite of our hypotenuse, this u sine theta. We have a u sine theta. So initial speed along y is 40 times sine theta and sine 30 degrees, which is 20 meters per second. Then initial speed along s is 40 times cos 30 degrees. We'll multiply that, know what we're going to get. So 40 times cos 30, that's what we have. 40 times cos 30, 34.64, yeah, 34.64 meter per second. 34.64 meter per second. That, so we know what this is.